Hello everyone, so today we'll see the Leetcode problem number 200, which is number of islands. So in the problem statement, we are given m cross and 2D binary grid, which represent a grid which have ones and zeros. So 1 representing the land and 0 representing the water. We have to return the number of islands here. So what is an island? An island is surrounded by water and is formed connecting adjacent lands horizontally or vertically, means no diagonals. You may assume all 4 edges for grid all surrounded by waters. So basically you will have like one grid which will contain either 1 or 0. So 1 is representing the land, and you can consider that entire connected land as one island. So when you will see any adjacent ones, you can consider the entire island as single island. So let's suppose the first island. Okay, so let's consider this example here. So in that case, you will hit this island, and because this island is also adjacent, you will just keep going. This is entirely one, and this is also connected, right? So this is just a single island, so the output should be 1 because it have only one island. If I talk about the second example, here you can see like there are multiple tiny islands. So first one is this, and because we can't go diagonal, so we can't consider this one, but this is a single island here because on the left or right hand there is no islands. Similarly, this one is also in single island, and if I talk about this one, this is an connected island. Where you can see these are 4 islands. The output should be 4. So you have to just keep in mind that you can make call left, right, up and down. Okay. I hope you are pretty clear about the problem statement. Now let's see this example. Okay, so before moving, just pause the video and think about any solution which you have in your mind. Okay, so this is the matrix here. Okay, so what we can do whenever you visit any, okay, so what we can do, we should iterate this entire grid, and whenever we hit any one which is the island, so we'll start making the DFS call from left, right, up and down side. Okay, so let's suppose you start from here. You will see like this is 0, which is water. This is also water. Here you will see one island here. So you'll start making call left, right, up and down. But you can see this upside, it is out of bounds, so we'll not make this call. And left, right side also this is water. Downside also it is water, so we'll skip this and make the counter increase by 1 because you hit one island here. And also one more thing, you have to replace this value with some different character so that next time you will not hit the same. Although in this scenario we will not hit this island, but let me give you one example. So this is water, you will skip it. This is water, you will skip it. Here you will hit again one island. Now again you will make call left, right, up and down. So you can see left, right, this is water. Upside it is out of bound, so you'll make down call, and you will see like there is one more island here. So before moving to that, just mark this as visited. So just replace this character by some other character. Now you will again get this downside adjacent grid. You will do the same thing here also. So we'll make call left, right, up and down, and you can see that again the left side also there is water, and the downside also there is water. So you'll make the call at right side, and again you will replace this character by something else, and again you will hit this one, then you will mark this one, and similarly you will keep going. Okay, and when you are done with this particular island, you will just get back to your iteration. So again you will keep continue your loop here. So you will see this particular index which is 0 here, again 0 here. You will just keep going and checking that whether this is island or not. And whenever you will hit the same island again, so you will again hit this island at the second row, but you can see this is an different character which is not one here. So you'll skip this and you will not continue with this particular island. Similarly with this and this, you will avoid it. So that's why we have to replace the existing one with some different character. Okay, so I hope you are very clear about this particular approach. Okay, so let's code it. Okay, so let's see what we are doing here. So we have initiated this island here with 0, and we are iterating through this entire grid, which is m cross n grid. and then we are checking that whether this is island or not. If it is not the island, that then it does not make sense for us to make the DFS call, because it could be either water or it could be the visited one. So let's see the DFS function. So in the DFS function, we have put it this boundary cases which is checking that whether these indexes are valid or not. Other than that, we have put it one more check, which is checking that whether this is island or not. If it is not the island, then it could be the water or it could be the visited one. Okay, so whenever you visit any grid, just also mark that as visited one. So change that value with something else. I'm replacing that value by 0, and see, it is not backtracking, so we'll not put this value back to the grid. So we'll change this value permanently, and then we'll make the call from left, right, up and down. So now we are checking that whether there is a chance for the adjacent island or not. So here we are making this for call. Okay, so whenever you are done with particular one island, you will get back to this particular function and increase the island here. And finally, we are returning the islands. So let's run it. Okay, so if I talk about the time complexity, so it will take order of mn, where mn is the size of grid. Okay, why? Because we are iterating through this entire grid, and we are also making the DFS. But so anytime when you visit particular island, you will not count the same island again. So you will not fire the DFS for any of the remaining part of the island. Okay, so that's why we can say this time complexity should be order of mn. If I talk about the space complexity, although we are not storing explicitly, but still we are using the calls through recursion. So at max, if let's suppose all are ones, so at max it can go till mn. Okay guys, so that's pretty much about for today's video. We'll meet in the next video. Until then, bye guys, keep up the good work, see you soon.